Hello, ladies and gentlemen. The section will soon begin. Please be seated. Hello, ladies and gentlemen. Welcome back to the second sub-conference of the Young Academy of Sciences Summit 2023 to 2024. In this section, we will discuss AI in construction industry. We are pleased to have Professor Danford Lau as our moderator of this section. He is a founding member and co-chair of the Outreach Committee of the Hong Kong Young Academy of Sciences, professor of the Department of Architecture and Civil Engineering at the City University of Hong Kong, and associate director of the City U Academy of Innovation. Now let's welcome Professor Lau to the stage. Professor Lau, please.
Thank you. Good afternoon, ladies and gentlemen. Welcome back after the lunch. Hope you enjoy the arrangement. Before getting started, I would like to briefly introduce this section. In fact, we are going to focus on the AI in construction. This morning, if you're in the morning section, you know that we talk a lot on the design of the maybe the chips, maybe some fundamentals, the algorithm issue, the ChatGPT or the generative AI. And now we are really focusing on the application issue, particularly construction industry is one of the major industrial sector in Hong Kong. In this talk, in fact, we are focusing on quite a lot of important areas. Is that for construction industry, we may link up to maintenance aspect, we may lead to the construction safety aspect during the construction stage. We'll also talk about the material aspect, maybe how to make use of AI to come up better, durable materials. We are very honored to have our invited speakers, Professor Chang Tak-ming from PolyU, Hong Kong Polytechnic University. We also have Professor Chen Jiayu coming from Tsinghua University. We have Professor Kim Jong-nin coming from my department, Department of Architecture and Civil Engineering in CityU. Without further delay, I think I should pass the time to our invited speaker. May I invite Professor Chen Tak-ming to the stage. Thank you.
So good afternoon, everyone. Thank you once again for Danford for the invitation and the excellent organization for this event. And in particular, that my team member is also here, so that will be another interesting meeting with them over the next 30 minutes. My topic is working on the artificial intelligence for circularity in construction. But actually, my background is on structural engineering. So when Danford asked me to join this event, I was like, oh, okay, good. There will be some time for me to develop my AI in this area. So hopefully in the next 27 slides, I can share with you my thoughts on this area. But bear with me that in some of the slides is prepared by some of my team members that are lots of wording on that. So I'll put the fingers on them later on if there's too wordy on that. In terms of this particular part, I guess the first thing we actually, when we talk about the circularity in construction, I think the term circularity is actually quite a nice term. So in life, we are walking around circle all the time, and then how to find the end is quite difficult to find. So, but in general, we're talking about how to make yourself working in a circle. And then when we talk about this circularity, another term is quite useful is about the so-called reuse. So the direct reuse also relate to this term. And later on, hopefully, I try to inject some of the, my thoughts about the AI in those key issues. One thing that I borrowed this slide from my colleague and also one of the PhD, probably for those who are familiar with some of the space mission this day, in particular from SpaceX, they have the Falcon #9, this particular rocket. So when they design this particular rocket, actually they have the booster that try to push the rocket up. And then they particularly design the component like the booster is reusable. So when you think about those issues that were even the rocket science that we can try to develop something reusable, then you get it, we can do something as well. But when I further forward, we have something from this guy. Then for myself, probably I'm a bit more down to earth. So last week I take a picture of what I got in my flat. So when we look into what we are having now in life, so probably in particular, that's some of the furniture we're having. So we can consider that when they assemble all this furniture, we have the mission is how easy they can be assembled. But at the same time, can they be reusable? So I think that's one of the things that we always observe. In particular, if you try to get the furniture from those shops, when they deliver, they always come with a very nice wooden block, flat surface. They come with a customized size, standardized size. So when we think further, then actually that is very crucial because standardization is very important for us to try to use reuse, and also very important for storage. So that's one thing that we can try to pick it up. And I could imagine that when we try to develop the booster, they also have the standardized component so that they can store it and can replace it quite easily. Another key feature that about reuse, I think, is about the adaptability. So because I have a young kid, so it's a bit dangerous for them to get the drawer. So that structure, you can add something on it to try to protect, to improve the safety. So that particular thing is also very crucial because apart from what we've done in the furniture, but in the building structure, probably through the design life, you have to adapt the usage. And how to adapt, then probably is based on our engineering and based on some previous experience so that you can develop some design. So those things are quite crucial for us to understand, we have the rocket that can be reused, we have the furniture. Then obviously, why not we also try to make use of in constructions. So for example, assuming that we have two sets of different buildings, so why not after the design life, sometime after 5 years, 10 years, can I simply pick up some of the slab column to make a new buildings? So that is how we try to reuse the building. So, but later on in the next few slides, I'll try to inject something more about what will be the issue that we are going to face. That will be my thought about this circularity in construction. But going back to the artificial intelligence, so thanks to Danforth. And so I also try to think about how can I interpret this part. And I get the permission from my wife that I can show the next video. And I haven't asked my son, but hopefully you guys don't. Some of my members haven't seen my son before, so I just want to show. Last month, I brought my son back to my office. And then when I get out for a coffee, then very interesting that for some reason, he is sat on the flight and then try to mimic what I've been doing at work. He never went to my office before, so I want to tell my team member, I also work at home as well, so you guys need to work harder. But funny enough, I think that he captured the typing and also using the mouse. I think that's the very interesting thing that when we try to learn something new, you pick up by observation. I think from a very young age. So that means for what we try to develop the artificial intelligence things, actually, we observe, we train, and then we see what we can get. And the important thing is, what is the model they are mimicking? So hopefully that he look at my working style, that he can mimic that part. So the data set is quite crucial. So I think that's why it's quite important for us to appreciate that maybe we have to be very observant for what we have been doing now. And then when we try to work with these different types of data set or intelligence, we have also need to assess if they're feasible or not. After having all this circularity, artificial intelligence, so I think go back to some of the issues that construction industry need to face. When we look into those issues that we have been facing, I think the carbon neutrality is always the key things that we have to observe as a citizen of the world. So that's why when you look into some of the data chart, sorry for that, for the colleague at the back there, I got some slides show too low. But in general, that when we look into some of the figure from the United Nations report, we observe that construction industry in general contribute about 37% carbon emission, 37%. So by having this number in place, if anything can reduce this number, then actually can contribute a lot for the general carbon emission. On the right-hand side of the slide, so we pick up some of the so-called the life cycle of the building structure. When we look at that one, maybe you can just think about a clothes or the furniture. They always come from the raw material, and then you have to design, to fabricate, come to use, and afterwards, you can disintegrate your clothes, you dump it, or you can reuse it. I think very similar things in the construction sector. You have the so-called the raw material supply, transportation, manufacturing. We characterize as so-called the upfront carbon. So it contributes the so-called the upfront carbon of the so-called life cycle analysis, about 50%. And then anything beyond is so-called the embodied carbon, transportation, how to construct it, how to operate. So we are using all the lights, all the services. That's how we operate. How we can try to minimize this embodied carbon that account for 30 to 35%. And after the design life, then we have to also provide some carbon to decommission the building and then transfer it to the site. So all the whole life cycle of the construction, you get the feeling that each stage contribute particular proportion. In particular, the upfront carbon can be something that we can try to do. How can we minimize the raw material usage? So that's why the reuse concept is come apply. On the left-hand side slide, showcase the current existing circular economy approach. So we're starting from the raw construction material, and then you process it to form the steel, concrete. And then as a designer, you can design for deconstruction or demolition. So that means you can design, and after design, you can cut it into pieces, construction, and carry out life cycle analysis, and then demolish it. So you demolish it, that means you actually damage. So you break everything, break back to the very small pieces of material, and then you try to recycle the construction material. So there's the current state of the circular economy approach at the moment. But now, when we try to reduce this particular product, then why not we can try to find something new? Just like, can I simply reuse the component, just like the rocket, the booster, the table, can I just use the flat survey? Then they come to the point about the new circular economy cycle now. We can still need to start with the material first. But then, when we try to design your building or any structure, you have to put your mindset to so-called to change to design for deconstruction and reuse. So this mindset is quite crucial because if you design the things for reuse, that means you have to incorporate some key feature. That key feature in construction or building structure, we propose so-called a DIS. A DIS is so-called a demandable interlocking structure connection. In short, maybe if I'm getting old later on, I can replace my joint using some demandable joint. So those things is something that we can think of if you're having a building structure, demandable connection. Later on, I will showcase some of the example. If you have those examples, and in particular, you are using standardized component, you can then try to build the construction, and then you can carry out life cycle analysis and environmental impact. You deconstruct. After you deconstruct, because your connection is already demandable, that means your the flooring system, the wall, all these things may be non-structured at the moment, but beyond this, you have the structural wall, structural slab, structural column. All these components can be taken apart and then can check whether it can be reused or not. So in this particular part, we are going to reuse the slab, the column, the floor. Instead of try to make it as a back to the raw material, you have to refabricate again. So that is the new system that we try to look into in construction. And you can see that there will be a lot of digitalization, lots of data set we have to develop for this system to be used. This slide just summarizes again. In the past, we have the linear approach. We get the material, make it, and then we waste it. But now, how we try to transform the linear to the circular. So that's quite a number of key issues that we have to look into. I think this one, just to summarize what we observed from those parts. The key issue is how we can really make sure that our connector can be demandable and how to check the component can be reused. But another key issue is in the furniture shop, they can store the stock easily. But for the building structure, you recognize we have so big slab and wall. How can we store it? So that's why if we have a standardized component, it could be easier for us to try to store this part and then promote these applications. Looking into this one, then we have so many different challenges we may need to face. Engineering, so probably there's a lot of risk on using the component in place. How can we ensure the confidence of the client? And in terms of the management, because at the end of the day, we have to provide the model that economical viable. So that's why we have to make sure that they have the supply chain and also have a fluidity about this work. So there will be a number of things that we need to look into. And then throughout how the AI can help us. So hopefully in the next 10 slides, we can come to some of the key points. But again, bear with me that there will be lots of wordings on some of the slides, but I will just pick up some of the key points in a minute. One of the barriers that probably, when we look into this issue, and when we look into this area about circularity, I think we are not alone. But as always, when we look around the world, there's a lot of different development also in Europe, in Japan, in US. So we also observe that in Europe, they also have the similar ideas about the circular economy in construction. And in particular, actually, in the EU, they have the agenda that promoting the circular economy. When we look into the barrier for this reuse member, I think one of the things that is how we can make sure that the reuse member is not that expensive to be reused, because if we deconstruct it, then how we're going to rectify it to reuse again? We have to make sure that the reuse of the component that economically that will be viable when compared to the existing component. So all these things, that is one of the very important issues that we have to look into. That's why when we try to look into to propose this new system, when we have some of the new structure being designed, now what we're proposing now, probably we have to get the engineer to adopt this reuse of component concept. So when they have the new connection, they can demand the structure system. Or when they try to use some reuse component, shall we try to make use of some high safety factor? So all these things can be one of the options for the engineer to pick up from. When we look into the demolition, I think probably if we look into some of the building structure, some of the building structure in Hong Kong in particular, we are using a lot of reinforced concrete. So if you look at the connection between the wall and the slab, they are mainly monolithic. So that means if you want to dismantle it, you have to cut it, damage it. That's why we create all this irreversible nature. So that's why, as an engineer, probably what we need to think carefully is how we can try to follow some of the, actually this kind of standard already in place in 2020. So this standard, the ISO standard, is actually helping us. How can you make sure that your structure or building can be sustainable for the future? They provide a lot of very key features that we can look into. In particular, when they talk about the connection, they list out a lot of items that actually will be useful. May not be able to look at the details, but when you look at the description, it's quite important. Adaptability. So far, we have designed our functioning of this room. How are we going to change the function after 5 years because of the usage of the room? If we can prepare the structure to be adaptable, then you will be able to save a lot of energy for changing it. Expandability. One of the things that we have got so far, probably for the transition housing, sometimes we have 2 to 3 story. Are we able to add 1 or 2 stories that can upturn on the existing structure? How your existing structure can be accommodated for it? So all these things is quite important. But one thing I quite like is the simplicity. We get used to, in particular, in research that, like from my colleague and my student, sometimes when we develop some connection, for some reason that we drew on, suddenly we have a very complicated structure that look nice, but very difficult to fabricate. Then we have to go back to the drawing board to try to make sure that we have the simplicity. So that's why when we look into the AI or the digitization, we have to ask ourselves, as always, do we have other simplified versions that can also serve the same purpose? Do we really need those advancements that doing the same thing with some 5%, 10% improvement? So I think that's something that we can look into. So I think I quite like this item, although they haven't given a number, but just to give us something that we have to remind us when we do the design. When we look into, I think one of the things that we showed earlier, and thanks to Denver that he showed me this picture before, very crucial that, because I mentioned that we're going to reuse the component, slab, wall, beam, but how can we ensure that can be reused? That means you have to go for the checking. That kind of checking, we also don't want to damage the component. That's why we have to carry out some so-called non-destructive testing tests. So Denver have been developed a number of different ideas on the NDT. And it's very crucial because if we can gather all those data, but one question people keep on asking, well, if you are having all these components being demolished from a building structure, 10 story, 20 story, are we going to check every single one of them? You can say, if we check everything, so you have so many data sets. But in reality, we may not be able to do so, or we don't need it. So that's why we have to develop the model to judge how many number of tests we need to be done to test the validity of the slab for next reuse. So that's why the AI come to help us to observe how we can create this model. So that's why those features is quite important, how to collect the data set. So those is very important things, and thanks to Danford on that. Don't look at this slide. Maybe just about the business now. So when you look at the business, one of the things is, again, the uncertainty. And as I say, my background is from structural engineering. But when I look into this circularity, I realized that we cannot get away from the business side. So when we talk about the business side, then one of the things actually, if you have a building that have a 5-year-old beam, 10-year-old column, 20-year slab, gathered together, how can you define the age of this building? Are you using the 5 years old to define or 20 years old? Just like when you got your new joint to be implanted in your building. So you have a very new joint, but on the other side, you still keep the old part. So how can you define your health, actually, in general? So I think that is quite important that for us to understand how those probability of failure may come to pass. And also about the liability that will be related to the insurance on that issue. And again, I try to learn a lot through this involvement in this area. Going back to the engineering, I think we got a lack of design tools that we are not quite sure what we try to improve. And in particular, I think one thing is quite crucial, that we cannot reuse the member forever. We have to set the time frame, obviously. At the moment, for the normal building structure, we are talking about the design life for 50 years. For bridges, 100 years. So that's why when we try to think about the design life, how can we predict for the next 500 years or 1,000 years? Sometimes you can predict, but obviously our next generation will try to challenge us, our assumption. But I think the best thing what we can do is based on the data set we got and then predict the future. And obviously the risk involved that we have to take into account. Again, sorry about those parts. So I think that all these things really relate to how we try to promote. So at the moment, the current design concept, we already got some concept, design for the construction and assembly, design for manufacturing assembly. I think it's a quite common term now being used. So hopefully that we can try to promote the term design for the construction and reuse, so that this principle can be embedded in everyone's mind. I think it's quite hot topic this day about the reuse in Hong Kong as well. So hopefully we can, through the education, to try to bring this up. But no matter how, we cannot get away from it. But hopefully we can try to gather all the experience to try to move things forward. So with all these things, maybe in here, just give another framework that when we talk about the reuse in construction, for those who realize in construction, probably we try to use some material like concrete and steel. But as I mentioned, if we want to try to reuse the component, that means I may have stored the component in position A, I need to move it to another site for construction. In some of the research, actually, that they try to make some of the estimation for the so-called profitability and safe transport distance. So part of concrete, 240 kilometers. For steel, you can travel very long way that you will not damage. Because normally, in the transportation, you worry about the damage on the component. And all these things is quite crucial. If we got the data set, geometrical area things, then we can work out this data carefully. This slide just to summarize that, how to compare the so-called the new usage of steel and the cost for used steel. In general, if this data is taken from 2018, so the number may have been changed a bit. If you want to buy the new steel, you have $261 US per ton. If you try to get the price for the used steel, you can get 58 USD per ton. So the difference between $200 US by using the used steel, then you can get this particular margin that you can help you to try to use the transportation, check, and actually making a profit. So I think this data can showcase what is the corresponding material be useful for us for reuse. So when we look into this design approach, we try to make sure that we confirm that with this design concept for reuse so that we can hopefully the whole design life cycle can be further improved. That is one of the key slides that I get lost all the time. When you look at this particular slide, if you look at the first thing, we have so many phases that we have to focus on. Production, construction phase, decision for reuse, assessment for certification, and supply chain. By looking at all this category, we have so many steps to provide the important issue to promote the design for deconstruction and reuse. By looking at this step, then obviously we quite like to follow those steps accordingly. But hopefully, if these steps being embedded in the design phase, then we can digitize the framework. In particular, one of the so-called certification that would be very useful. For example, if we got this remote controller here now, so you may have the barcode, then after a few years, you can reuse it and check the feasibility of being reused. Similarly, we can also embed a barcode to the slab, to the wall, so that after 10 years, you know the quality and the status of that. So those things would be very useful for this kind of digitization in construction. So all these things give us the idea on how AI can help us in this framework. This slide, another burning slide that my colleague and I, we work on. What we try to achieve in here is, at the end of the day, when we try to close the loop in the construction center on how we promote this circularity, we always need to get the incentive for the owner to do it. So obviously, we have to get the government approach first. For example, currently, when you look into the modular integrated construction, we need the government to help us to promote this particular part in their government project. Similarly, if we try to promote this circularity in construction, probably we can start with some government project. So there's some government incentive scheme that we have to promote, some green tax. So all these things can hopefully can help us to promote the ideas even further. So this feels like, just to summarize that, thanks to Danford and some colleagues from Hong Kong U and PolyU, we are working on a project that actually looking into circularity in construction. We're starting from last year. And here we got some concept about that. We talk about the mantle, the connection. So that's why it's quite crucial for us in the next year or so to try to test, evaluate all these components accordingly. So also with Jargon slab in here as well. So I think it's quite nice on there. So because of the time, I think we're reaching the end. So I think at the time, again, I would like to thanks for my team that they're all in here. Most of them are in here now. And thank you for the support in the last couple of years. And then hopefully we will still continue to work together for the future. So one more thing is that, sorry. I think you get rid of this. One more thing I learned from my kids, because I think if you listen to some of the songs from the kid, one of the songs is very important. Mommy fingers, where are you? Here I am, how do you do? So I think for the artificial intelligence for construction, I think it's quite crucial for us to see where are you. But actually, this kind of information is everywhere. It may be just right next to you. I think the most important thing for us is really how to capture the core knowledge for what we have learned in physics and science in construction, and then try to work with the latest technology. But hopefully that we will be the one that who drive the technology forward, not the other way around. So thank you all for your listening. Thank you.
Thank you, Professor Chen. I think this is the time for questions from the audience. Any questions to Professor Chen? Yes, please.
A naive question, so the concrete slabs, they seems brittle, right? So can you really transport the concrete around and like break it up or move it up and transport it?
Yes. I think probably yes. On the outskirts that you can look at the brittleness, but obviously, actually, concrete on its own is quite intact material. So only under certain extreme loading condition you observe the brittleness. But the normal transportation, no issue. In particular, in Hong Kong, we have another construction technology, so-called precast construction. Actually, you can get the concrete slab in the factory. You actually can bring it to the factory site. So it's doable. Yeah.
Any other questions? If not, maybe I have just a quick question to Professor Chen. Just wonder, because nowadays we keep talking about MIC, is it modularly integrated construction? How the circular economy with AI can really be integrated eventually to this concept of MIC? What is your opinion in this area?
I think it's a very good question on that, because I think MIC is a very hot topic in Hong Kong and actually in the world as well. When we look into circularity, I think the concept, we want to reuse. So that means at the moment now, for what I understand, we can try to reuse the module. Because if you look at some transition housing or the temporary hospital, 1 or 2 story or 3 story, then maybe you can try to dismantle it, move the box out. So, but when you look at that one about the AI, probably we have to observe the inspection. What is the quality that the steel after 1 year? Are there any corrosion being there? So that means when we try to look at, maybe we have to get some health monitoring that we have to observe. Then the AI may come apart.
I see.
But second thing, maybe when in the design stage, when we try to have the building information modeling, then actually we can also adopt a lot of AI to make sure that after 5 years, 10 years, we can dismantle it accordingly.
I see. Thanks a lot, Professor Chen. I think in this talk, we really learned a lot on how we can really have some good areas or direction that we can apply AI in the construction industry. And I'm sure that circular economy is a very important aspect to echo with sustainability concept that all of us are working these days. Let us thank our speaker again. Thanks. In fact of time, I think I will invite our second speaker, Professor Chen Jiayu, coming from Tsinghua University. And I'm sure that this talk will be very interesting as well, same as Professor Chen's talk, focusing more on the construction safety aspect. And I'm sure that this is also one of the important areas that we should focus, especially linking up to building, talking about safety for our construction workers. Without further delay, let us welcome our speaker, Professor Chen.
Good afternoon, everyone, and it's my great honor to be here, to be invited by YASS Academy of Sciences. And I was received this topic from David about talking about AI's implementation in construction. But in fact, to answer in this question, I would like to break that in two questions. The first question is our current conditions of the construction industry. And the second question is how we currently implement the AI in the construction industry. So to answer the second question, I will include some the other researchers' outputs as well as mine. So let's take a look at what's happening in the construction industry. Okay, here is an overview. Okay, so do you guys know what type of company the construction industry dislike most? I can tell you the answer, the consulting firms. And the we hate most is McKinsey. And because there is a report, I guess this is in 2008, McKinsey have a report on the productivity evolution during the past 20 years. So they make a comparison between the construction industry and the manufacturing industry. And their report is, by the year of 2012, the manufacturing industry have a productivity 1.7 times higher than the construction industry. If we take this one as a criticize, and then here comes a humiliation. Because McKinsey write another report in 2015, and they mentioned if the construction industry mimic the way that manufacturing industry produce their goods, and then we can increase the productivity by 5 to 10 times. I was shocked by only 7 years later, and then this gap become 10 times. So that's why we always hate this type of consulting firms. They don't really realize what's actually problem with the construction industry. Let's take a look at. And here is a comparison between the manufacturing industry and the construction. And if you make a comparison between the ways in 1960s, people producing things, and nowadays originally people using labor forces like human, right? And then they have those robotic manipulators, robotic arms to conduct the production. And even nowadays, there is some factory called no light factory because there is no person at all inside of the factory. All the construction or buildings was done by the machines. But if you take a look at the construction industry, this is the way we're doing the work in 1960s, and this is the way we're doing the work nowadays. Exactly same, except different type of person and different type of probably some tools. And probably this is one reason why we have huge gap between the construction and the manufacturing. Okay, but if we think about the industry itself, here is a report for the market size of the US construction market and the Chinese construction market. This is the market size that's related to the construction industry. And it's very interesting. This report was done by 2022. And then that's a period of COVID, right? And you still can observe a 9 to 10% of increase for both the markets, for both US and Chinese markets. And we can expect this increasing a lot in future. The reason why, well, you probably heard about the news, like the real estate market in China is declining. But the condition is, even if this new building market is declining, but we already have a huge building stacks. For the maintenance, operation, we still need a lot of workers to participate in the industry. However, the scenario is we can focus. The capacity of our production will not increase a lot. Especially if you think about this as demand. This is our capacity. Our capacity is our productivity rate times the scales of labors. But there is an awkward position for the construction industry. I'm not sure if you have similar experience. While I was young, my mom always told me, like you know, for the work in the construction industry, we have a nickname called moving bricks. I'm not sure if you know about the nickname. And my mom always told me, like, study hard, or you move those bricks on construction site in future when you grow up. It's kind of humiliation, right? It's because the jobs of construction industry seems a job with very low dignity. So that's why people don't like working on site. And more importantly, Like, I'm not sure if you know the current condition of our industry. There is a nationwide research or questionnaire for the average age of labor forces on the Chinese market, construction market. Take a guess. What is the average age of those people still working on site? 52. Young people prefer to deliver food rather than working on the site. So that's why you see we will focusing on shrinking labor forces in future. The only solution is increasing our productivity or raising the salary. Here is the news I got in 2022. You see here is a daily salary in Hong Kong. That's quite a lot, right? So in future, there is several trends that are associated with industry, especially we mainly summarize 3 types of trends, including industrialization, digitization, and implement artificial intelligence. So the first one, there is the first path has been discussed in past years. I guess Professor Chen already mentioned about the modularized construction. Producing in the prefabrication factories, and before we construct things, and then we move those components of construction, like Legos, and then we assemble those Legos on site. But the problem is, thinking about that, we are basically the reason why we're doing this is we are trying to transform the way of construction industry to the manufacturing industry, right? We are trying to mimic the way they're producing things. But think about that. When you have 1 million value robotics arm or manipulators that they are building cell phones like iPhones, that's okay. But think about if you're using those arms to build concrete blocks. And those concrete blocks, they are huge, heavy, and worth nothing. And more importantly, think about the prefabrication factories. Like there is factories in Shanghai, and then you're trying to build something in Xinjiang, and then the shipping cost is 5 times than your material cost. So it's not worthwhile. And one of the most popular and powerful has been feasible solution for modularized construction is steel structures, because steel, comparing to concrete, have relatively higher value. But even if you have a prefabrication factory that's close to your site, according to the business partners that we talk about, they mentioned the price of building will increase by 30%. That's still a huge increase on their cost, right? So that's why maybe this is not an ideal solution. People thinking about why not we doing something else? Like if we can, instead of moving our products from the site to the factory, why not we enhance the capacities or abilities of human workers? So this is the second way that we can do our work. There is a concept called intelligent construction, has been very popular in the past decades. And we already have some tries before, such as prefabrications, 3D printing, BIM, simulation, robotics, automation, digital twins, health monitoring, sensing systems, information networks, environmental sensing. We have implemented quite a lot of technologies already on construction site. And all of them, nowadays, we give them a name called intelligent construction. We are trying to implement this new intelligent construction concept to revitalize our construction industry. But that is very general, because for the construction, that involves quite a lot of people there, including designers, architects, civil engineers. But if we focus on the construction site or only the process of construction, and here is usually we do, like this is a construction process. And then we have different type of technologies we already mentioned, and then we put them together and we gave them name called intelligent set. But you see, currently, all type of intelligent set is not that intelligent. It's more like a purchase of different type of computer science technology, the electronic technology, and put them together. And there are some local governments, like Shanghai governments, getting more aggressive or ambitious, whatever. And they said, nowadays there is a government regulation. If you have a new project that developed in Shanghai, you have to invest 5% of your total investment to an intelligence set. And so that's why a lot of contractors, they come and buy in those technologies and try and put them together. But the result is they don't realize how much productivity they improved. And that's been proven that's only it's more convenient to have a security entrance because people have a computer face recognition to get access to the construction site. The others, for the BIM, we already know that. We have been implementing this technology for many years. There is an expert, Professor Johnny Kim, he will give you probably a talk related to this one. So why I'm adding a new term called human-centric intelligent construction over here instead of just intelligent construction, because we already have a map over there, and there's a mature concept of that. Okay, before that, let's introduce some idea of level of automation or level of intelligence. So this idea was borrowed from the automobile or unmanned vehicles. Like, based on the unmanned vehicle systems and based on the American Automobile Manufacturer Association, they have introduced systems of level of automation. And nowadays, if you're buying a Tesla car, they probably tells you, okay, here is like our automation level, like L3 or L2, something like that. It basically tells you how much functions they can be utilizing artificial intelligence to substitute the human driver. So similarly, if we make a comparison, we find a lot of people actually already done this comparison of level of automation or intelligence. Like this is the level introduced by the automobile industry. And this is the level of automation introduced by the manufacturing industry. And that, on the last column, is level of automation or intelligence of construction industry. If you're mapping the level and across all the industries, you still can see our industry is still lagging behind. But it's not saying, okay, that's professors or practitioners in the industry is dumb or not smart enough. It's just because it's really hard to implement those high-level technologies. Okay, give you one example. You see, those are robotics that we already been implemented in on the construction site. Some of them can do the job of painting, layering the moulins, or layering the bricks. But unfortunately, if you watch carefully on those graphs, you will notice there is always a people that's associated. That's the driver of those robots. There is a company called Bozhilin. I'm not sure you heard about that. One famous real estate company in China called City Garden. They have Bozhilin as their sub-company. And then this company have developed, this is the largest construction robotics company on the market. They developed 52 or 53 different types of robots for construction. And they implemented those construction robots on their real project. But all those projects, all those robots, they have a name and introduced by Bozhilin. It's called single task construction robot. Why is single task? Because one robot can have only one function. They can only do one job. So in other words, if you want those 50 different type of works, and you need 50 different type of robots. But for the human laborers, one labor can do all those 52 type of works. And here is some problems that after, actually we, in Tsinghua, they have a very close collaboration with Bozhilin. And those are problems that we identified during the discussion, and such as those problems with current robotics in the construction industries. Their price is high, and they have long research and development times, and the covering of task operation is very low. At this moment, those type of robots only can be implemented and used in the final declaration of construction. If you use them to pour concrete or even prepare the rebars, impossible, because it's too complicated. So what's the conclusion? The conclusion, including the picture I showed you and the Bozhilin's experience, they are telling us in future and for a very long period of time, human and robot have to be work together, coexist on the construction site. And that's one reason that because we can't replace human with robots. That can't is we are not able to do that. And there is a second we can't. Do you know how many jobs that construction industry, like in China, create? 30 million jobs. And think about that. If you use robots to replace 1/3 of those jobs, and 10 million people losing their jobs, it's not an economic problem, nor or a technological problem. It's a social and political problem. So we cannot relocate our construction laborers to other industry or letting them losing their job until we find some substitution jobs for them, right? So that's why, as I said, human will coexist with robots or those technologies for a very long period in future. And that's the reason why I introduced the principle of human-centric intelligent construction. And when we try to implement artificial intelligence, we have to think about human. Okay, so why we cannot mimic the way the manufacturing industry is doing the job? Think about that. We have dynamic environment. Like, we do not have factories that have a fixation of robots there, and robots have to move around all over the site. And whenever you move it, you have to recalibrate it. Whenever you move it, you have to find the source of energy. You have to find some professional people to do the investigation to ensure they will work properly. That costs a lot of effort. And in addition to that, the construction site have a lot of uncertainties, different weathers, and earthquakes, and even the strikes from the workers. It's unexpected scenario happens every day and every minute. Okay, so in this scenario, it's really, really hard to use robots to replace human beings. And here is the problems, and here is our current condition of the construction industry. Now, let's take a look at, since we already know the condition, see what type of AI technology will already be implemented in the industry. And those are, actually, I give them a category, maybe not that appropriate, but I give them 3 different branches or directions. The first direction is human-centric building information technology. So basically, this is bringing in the human-centric information into building information systems. So I'm not sure how many of you are familiar with the building information modeling. Just give you a quick hint on what building information system or modeling is. For the construction of a project, it involves so many people, as I mentioned, like contractors, architects, civil engineers, developers, a lot of people. And building information modeling is more like a data repository. All type of data will come into it, and people will sharing their digital models, their budgets, their costs all together, and those information will be shared across all the parties. So a human-centric information is the information not only that's related for the future residents, but also construction workers that's associated with our building systems. This is a new type of information that come into the building information systems. Because originally, our project mainly focused on the completion of the project. We don't really care about how workers done their work. And how do we do that? How we get those information? There are a lot of technology has been implemented, such as like those Wi-Fi, Zigbee, RFID. Basically, those are positioning technologies. They can identify where a worker is, and then extract those information to our data repository systems. Basically, all those information are close to spatial information. For example, this is a study conducted by Professor Wong in the McCall University. It's very interesting because he implemented and using cell phone as a sensor to detect humans' mobilities inside a building or a site, and integrated all the information into a building information modeling, so that people can not only visualize the building model, but also to take a look at where our workers are working on their jobs. Others are related to the safety, as Professor Lau mentioned. For example, since we already know where the human workers are and where our equipment are, and then we can detect their distances, so that just in case some machines maybe hit the person or cause any problems. So this is another implementation. You can use those sensors on the head so they can find where persons are. Others, this is a very interesting study. It's kind of 10 years before, but it's this professor, Eugen Tyler, is very famous in our domain. He's the first professor to implement the positioning systems and some physiology sensors to detect humans' physiological conditions and their trajectories to measure if people are working hard or not, or just relax. So this is very interesting. They can make measurements of their productivity. Although I'm pretty sure workers don't like that. There are also other type of research, like my research. My research at the very beginning is not necessarily implemented on the construction site. At the very beginning, what I'm doing is utilizing the similar systems, but layering multiple wireless systems so that we can get a position of human inside the room. Like for example, like this room, we have a lot of diffusers and infusers. Those are air conditioning systems, part of air conditioning systems. And like our site, not all the seats were taken, right? Some people are sitting in front, or some people are sitting behind, but there are always some empty seats. But for the diffusers, is also we can separately control those diffusers to make sure only the space that with people will be conditioned to save energy. Of course, this type of technology can be implemented on the construction site. On the site, there are some regions, we call them a control region. Like we have a tower crane out there. Those regions are danger, we call that danger zones. People are not allowed to pass in those danger zones. But the problem is people are lazy, right? So they always like to take some shortcuts. So if you can have positioning systems, then you can detect if they are in the danger zones and give them an alarm. And there is obviously there are another or maybe opposite direction. Like for example, you can give human beings some building information systems information as well. For example, this one, this is VR systems. Like for example, they are training some people, or for example, they have firefighters to turn off those, or turn on those tubes. But those firefighters are not familiar with building, right, or those systems, so they don't know that. But we have design, right? Then we give them our training and give them our VR environment, let them to come in, and those building information will directly passing through the VR systems, let them to do their work. Or similarly, like since cars can send alarms, people also can do it so. For example, when they're drivers, sometimes there are always some corners that you cannot always see the workers passing by. So within those information, you can send alarm to the drivers. This is another very interesting experiment conducted by a professor in PolyU. It's using similar algorithms to detect where persons are so that they send alarms to the drivers of construction equipment. Similarly, this is one implementation on sending the building information systems, like this station systems, to regular person. So if there is a fire in the subway stations, and then those systems will automatically guide the person to evacuate. So basically, this is another direction of using those type of information. And this is another very interesting endeavor of you combining human knowledge and the building information systems. Basically, this is a virtual environment. There would be a global teams that work together to design and validate the buildings. They can work together in this virtual environment no matter where they are geographically distributed. And they can having a one-to-one models that on the site. And they can come into the building to check the problems, or they can have a smaller version and identify where a problem is, then they can discuss and make the changes for the design stage. So that's the one direction. The second direction is human-centric psychological sensing technologies. Basically, this type of technology is mainly focused on sensing human or workers' condition, physiological conditions on site. One popular implementation is utilizing computer vision to find out where workers are. The reason why I introduced this story or this researcher is They are trying to solve the problem very popular in computer vision, which is called occlusion, like when something blocked your image where the target you're tracking on. Basically, they based on some artificial intelligence algorithms to take a guess where they are, and then utilize those information to guide the operation of the site. There is another one. This is a research developed by Huazhong University of Science Technology. They use a deep learning neural network to find the workers' behavior and if they are wearing the mask and the vest to identify unsafe behaviors on site. Here is another one. Here is a research conducted by my friends, Professor Changmo An. Basically, what he did is he attached a sensor on humans' leg so that they can detect the mobility and movement or gait patterns of human workers. Then using those information, they can find out where or the moment people tend to losing their balance and give some third party or give the worker themselves an early alarm. And the other type of researchers also doing the similar study but using different type of sensors. For example, nowadays we're using not only VR but also like EEG systems. EEG system basically is systems or electronic devices that can detect your brain activities. So nowadays we're using this one to detect when workers facing hazards and their decision-making process. We are trying to investigate their behavior, decision-making processes. Or we can utilize those data to have some pre-service diagnose before they go into work. Because a lot of workers actually drank a lot before their work, or they do not have proper rest before their work. And here is another one. Basically, this is using IMU system to detect the humans' behavior, like their activities. So this is conducted by my research team. What we have done is collecting a data set. Basically, this data set was merging by our data set and the allowed data set together, like including the motion data set provided by Carnegie and Mellon University, National University of Singapore. Basically, what we are trying to do is trying to give them our construction-related tags so that people in future can utilize those data sets to develop their own algorithms or AI implementation technologies. Okay, and here is another one. We are combining the motion capturing systems with the EEG systems to see when they're facing obstacles or facing different scenarios, what will happen, and trying to use EEG to understand their hazard behaviors. Okay, the last one, human-robot collaboration or collaborative technologies. I guess this is one of most popular trends have been developed for the industry in recent years. And we already introduced the robotics. So although we have so many robotics introduced by Bo-Zhilin already, but to be honest, from my perspective, I think this is some ideal scenario that we can utilize construction robots. You know, in general, for example, this is layering bricks. On the construction site, there are usually 2 workers on the layering bricks. There is one senior worker to put the bricks to the right position. There's another relatively young workers that just passing those bricks to those senior workers. So with those robots, what you can do is you cannot replace those senior workers because they have higher quality of construction or working outputs for this wall or for this whatever structure is. But you can replace those junior workers. For those junior workers, you can use robots to push or move those bricks to them so that they can easily install those bricks. And here is very typical implementation. For example, this is relatively new. There's a study that personally I think is the ideal solution. You have a human that guides the robotics arms or manipulators do their job. At the same time, once you guide it into the right position, the robotic arm will automatically layering the pattern that you desired. Or they have the injectors so that inject the bolts into the structure to fasten the nuts. Here is another one. So since we are trying to utilizing these robots to work with people, and then there's a professor in University of Michigan, she developed like a sensor of hand so that they can learn from this how human workers work on those bricks, and then let robotics to mimic the human behavior. But in fact, what they notice is they are not necessarily using those sensors. If they can capture the position or 3D coordination of those materials or those bricks for the ceilings or panels of the ceilings, and then the robotics can automatically mimic the behavior. And just by solving the trajectory, how those bricks would move. Okay, here is something else which is our research team are developing. I'm not sure if you watched this movie. It's called Edge of Tomorrow. And this was shocking by those skeletons or robots when I first time I saw it. But actually, this type of devices, we call them exoskeleton robots. These have been utilized for military usage for so many years, but not for civil usage. There are several different types of technologies. Some of them are enhancing the arm strength of the workers. Some of them are enhancing the strength of the lower limbs. Some of them are just providing a support for tools. And it's also being implemented for not only the military usage, but also for the medical purposes. So our research team collaborated with a professor in Shanghai University from the Department of Automation and from, I don't remember what her department is, automation and mechanical engineering. I think that's my guess. And then we developed a simple exoskeleton just for the lower limb. And as you can see, those type of devices are very useful, especially for the construction workers. It's not only increase your capacity, they can become a host when you're bearing the load, but at the same time, they can be protective devices. For example, like for the construction workers, if they have a lot of awkward positions or postures, for example, like we are installing something overhead, and we raising up our hand, it makes our body very uncomfortable. If you're doing this for a very long time, then this will end up with something we call as work-related long-term diseases. With those robots, we can have a holder for that. And in addition to that, like some work jobs, like drilling a hole, they have huge vibration during when they're conducting the job. And those devices can provide some protective functions for those type of jobs. So that's why we have composed some human robots interactive models for those exoskeletons. The problem for us, why we develop these algorithms or AI technologies, is we want to ensure, because when people wearing those robots, the first thing they want to ensure is safety, right? Because the robots can move in any angles, but for human, our bones cannot always move at any angles. We always have our skeleton design. So that's why we need to make sure the robots, they always can precisely follow our movements. So that's why we have a lot of control algorithm developed based on the device. And later, we have a newer version and updated version for this device. And this is our latest version, and later I will give you a demo for that. But for those devices, is that always have to be wearable? Actually not. Give you one example. I'm not sure if you watch the movie. This is a movie called Wandering Earth. In the movie, there's two guys. They are operating robots. We call this robot a door frame robot. It's a door frame. It looks like a door frame. And basically, if you think about technology, it's more like a VR system plus a teleoperation plus robots, right? And then what you can do is you can have a controller remotely and let those arms to mimic your movements so that they can do the job that you desire. Then you do not have any problem for the safety issues, right? And so I have talked a lot about the implementation of AI technologies. Just quick summary and future research direction of how AI can be further extended. Previously, we mentioned about use of robots. Those robots is really helpful if we construct things in some extreme conditions, like deep ocean, like high mountains on the moon. So we can invest more technologies, or especially AI control systems, to help us to solve those control systems problems to achieve this target, to further construction on those conditions. And in addition to that, we have introduced 3 research directions or technology branches, right? Human-centric building information technology, human-robot collaborative technologies, and physiological sensing systems. But we haven't discussed about if we combine all of them together, what will happen. So this could be a very interesting research direction if you are interested. The other one are related to decision making, because nowadays people, especially AI, can help us to make a decision. They can drive a car for us. But are their decisions always reliable? Not necessarily. When there is a decision that made by a human and made by a computer, a conflict, who we will trust, a human experience or computer algorithms? That's another question that we'll probably want to discuss. And finally, my guess for the construction, why our productivity is so low, is because we do not have a revolutionary improvements on the process when we're constructing things. For example, at the very beginning for the manufacturing, at the very beginning, the work was done by individuals. Like one individual can finish all the jobs for manufacturing 1 unit of product. But after we have production lines, that changed a lot. One individual only in charge one portion of the tasks. And that's the nature why manufacturing industry can evolve in the past decades. But our construction industry haven't experienced this evolution yet. So we have to think about how to reshape the construction process, no matter with the help of robots or with the help of other type of technologies. Okay, that's all my presentation, and thank you very much for your attention.
Thank you, Professor Chen. Any questions from the audience? I think we are a little bit behind the schedule, but we still have a moderator section for Q&A afterwards. So maybe we can leave some question at that time. Without further delay, let us thank our speaker again. Now may I invite Professor Kim Jong-un, our professor in the Department of Architecture and Civil Engineering in the University, in City University of Hong Kong. Professor Kim will talk more about the construction stages. I'm sure that when we are talking about a big construction project, there are different stages that are, again, linking up to safety issue, linking up to the productivity, eventually whether we can catch up the schedule or not. Professor Kim is an expert in this area. I think this is really good to have this talk before going to the discussion section. So Professor Kim, please. Okay. Thank you.
Thank you for introducing me, and thank you for inviting me, and thank you for coming. My name is Jung-in Kim. I'm working for City University of Hong Kong, as Dan Pedro explained. And then today, I'm going to actually something duplicated with what Jai Chen explained, something about, I will explain application of AI for different project phases in the construction industry. So these are the contents of my presentation. Let me just give you some introduction and problems actually we encountered in the construction industry, and then explain something about AI, things, different project phases, design, construction, operation, and I will give you my conclusion. So let me give you, so this is one problem actually we encounter usually. Large project, usually we have a 20% or longer time we have to spend. This is average value, and also more than 80% of money we have to spend. So this is what different from what we expected. So we want to solve this kind of problem. Also, this diagram, Dr. Chen already explained something about. We had big difference between productivity in the comparing with manufacturing industry. The manufacturing industry improved their productivity a lot, almost 30%. But our case, actually comparing with the productivity in 1987, actually our productivity in the construction industry like 20% decrease. So there are lots of problems, as explained Dr. Chan, and also there are several problems we have to solve. But one thing we have to solve is that this diagram shows digitalization, the relationship between digitalization index and productivity growth between 2004 and 2014. So where is construction industry? Here, there is some like a correlation between those digitalization index and productivity growth. But construction industry is here, so that means we have a low like a digitalization index. And so that's why it can be one of important reasons we cannot increase our productivity. So there are actually lots of solutions for this. So what I'm doing is, actually this is, let me introduce the nature of construction industry, because some of you are not from construction industry. So this is our project, usually unique project. We try to use the same thing by using modular construction or something, but usually our project itself is unique project and difficult too, non-standardized, or also multiple project, and we need to spend multiple years, and also we have to do something with multiple organizations, and also we have to spend lots of money for our even one project. So especially the problems in information system in our industry is that information intensive and also dynamic and paper-based and fragmented. As you can see, this is one thing why we call that information intensive and dynamic. So because from design phase to operation phase, we generate lots of information actually. Schematic drawings and design drawings, also construction schedule and maintenance schedule and the cash flow model. But this kind of information will take a large, huge amount of data generate. Also, another thing is we still actually, I will explain something about building information modeling, but still we use paper-based like this. Also, even if we don't use the printout hard copy of paper, but we use some file which are separate from each other. That means it is, if I want to find some information, it is very difficult to search from this kind of folder or information. So that is another problem. And last problem I want to mention is that we work together with different disciplines. So structural engineers, geotechnical engineers work separately usually. And then also project stages from the beginning and different construction design, detailed design and construction operations. And then finally, our information is like this island. So really difficult to find information. Fragmented information will make us to find like the information we want to search. So under this problem, one of the solutions, actually there are of course lots of solutions. This is one thing we can do. We can do something virtually. So virtual design and construction concept can be adapted to solve this problem. So this is basically by using building information modeling and then like develop construction schedule together. And then we have a quite good communication with each other and then confirm constructability of a detailed design. And then we can make highly reliable construction. Finally, client can get high-performing infrastructure or building systems. That is some of VDC, Virtual Design and Construction Framework. So to follow that, basically starting or baseline will be building information modeling. So this is some building information example of building information modeling. So building information modeling is as Dr. Chen mentioned, this is not just a 3D image, just a kind of database. So we can use that. Also, the basic, actually, the concept is not just some information, but this is the process, how we can deal with different type of digitalized information or representation. So using this, so there is actually three different stages of building BIM application. First one is visualization, and second one is information integration, and last one is automation. So let me just briefly introduce what it is, and then just first stage, visualization. As you can see, this is 4D simulation to show the construction process for underground rock cavern project in Vietnam. Also, we can apply this for building construction project as well. Also, information integration. This is one example actually I have done before. So this is just a large development project. We can apply this at the beginning, from the beginning, and then we can incorporate all different type of information together and then analyze different metrics at the same time. For example, we can see the infrastructure cost and also traffic volume in operation phase. So this is another second stage of the application of building information modeling. And last stage, this is actually most important stage we can take some advantage from by using building information modeling, automation. So usually at this moment, actually based on my observation, we can analyze 10 to 20 alternatives, design alternatives or some decision alternatives, but actually even we can do 50 alternatives, quite a lot for us to actually analyze. But problem is that the decision space itself is more than billions, any kind of design project, any kind of scheduling project, because we cannot analyze, so within that more than billions of alternatives, we cannot actually see, evaluate. So because this is the situation we have, this amount of work will be like this very small amount of things. But we can do this based on our experience. So make some decision which one we will make. So this is actually a problem. So we can, based on AI or automated procedure, if we can analyze more decision alternatives, of course, we will have a higher opportunity to find a better solution. So this is usually, let me from now on introduce what actually my research group is doing for something about BIM and AI implementation. So basically, my research team focus on information integration and automation things. So this is basically how we implement the AI for our construction project. Basically, at the beginning, formalization of product means design and process information. And then this is usually, we formalize something about BIM model. And then next step is we automate analysis procedure. And then last step is based on this automated procedure, we will optimize our decision-making processes. So let me introduce some example from in design phase. So this is one example of the multidisciplinary design optimization for soundproof tunnels based on building information modeling. So basically, to design the soundproof tunnels, we have to consider, of course, other structure is same, but basically we have to consider safe structure. And also we have to minimize the cost of construction, especially we need to reduce the material cost. In this case, I interviewed some actually field guys and also subcontractors, and then they mentioned that especially when they got some like a steel pipe, and then they usually like a 5 meter or regular size, and then they need to cut that. Nesting plan is that kind of things, but there is some loss rate, almost more than 7%, 5% of loss rate. And then they also consider that kind of concept in decision-making procedure. So I incorporated all kind of decision-making procedure at the same time, and then basically using Bayesian optimization method as basic engine of optimization, and then incorporate structural analysis process and cutting plan generation and cost estimation process. And then actually, but during this development procedure, I found that this structural analysis took really long time. So we want to solve this problem. So we develop surrogate model based on machine learning, especially gradient boosting decision tree, to save structural model after learn the 10,000 of the analysis. We developed this model, and then so by using this like a surrogate model instead of actual structural analysis, and then we got this kind of accuracy higher than 99% of accuracy, and this is more than 16,000 times faster than actual structural analysis. And then using this surrogate model, and then we can do this again and again. So finally, this is the result of our work actually. So original design actually done by actual engineers. And then we can reduce loss rate from 7% to almost 1%. And then we can save our cost, total cost almost 18% cost we can save. Because of the reason is that we can see like a much more decision alternatives, and then we can save our cost. That is actually my research team wanted to do and have done something. So also another example for design phase is the design of slope for the road construction project. So this case, when we design road, we have to consider appropriate the reinforcement system. Also, this slope design can minimize the cost. We have to consider this kind of ideas. So to solve this problem, actually this is still undergoing project, but basically to do that, but the problem is that usually at the beginning when we analyze this kind of things, find minimum, like the solution with minimum cost, we have to do this process, extract data from the cross section, and then run this kind of analysis again and again. This is actually time consuming something, also like sometime error prone. So so finally this kind of work we want to just there is manual process and then spend lots of time. So we actually general problem is that our design team, actually not our, but the road construction or design team cannot carry out slope design optimization in a timely and consistent manner. So we started to see how they work. And then we, based on process map, this is just the formal, develop formal like observation or identification of their, how they works. And then see which guy are doing something, and then figure out that, and then based on some case studies, and then we exactly figure out what kind of information is needed. And then we develop some conceptual model to see as a database, and the hydrological conditions and some geological condition information and geometric information we included. And then based on that, this is just IFC is global standard of building information modeling. We extended that representation in the existing industry foundation classes. And then using that, we developed the prototype. So from integrate all information together in one system. And then we develop our own just the add-on software in AutoCAD environment. And then using this, develop create IFC, and then create script for analysis. And then we can do this kind of analysis, multiple slope stability analysis for multiple cross-section together automatically. And then we get the result from this automated process. And then using this now, this is what actually we are doing at this moment. So basically we are doing based on this automated procedure, we are trying to find optimal solution now. Basically we are starting from the genetic algorithm now, but we will develop better algorithms. So basically our objective function will be minimum cost, minimization of cost, and then using this, considering this kind of reinforcement geometric information, and then based on that, that is what we are doing. So making this automated procedure, and then we can just do this automated generation of different type of the slope, even for one cross section, doing this again and again, and then finally get the optimal design for each cross section, and then doing this for different cross section, and then we will be able to find optimal solution for slope design for road construction project. And then let's move to AI implementation in construction phase. So basically, so this is one example, just to, like the visualization of a tunnel excavation project. And then this is a Hong Kong government funded project, Q-learning based schedule generation and for excavating hard rock tunnels under resource constraint. So based on how so basically, when we excavate tunnel, we have to assign different type of equipment to different phases. But our question was, if we are here at this state, and then how we can assign our equipment to different phases. So of course, so what is the best policy? We want to develop best policy, identify best policy to assign our equipment. So in that case, if we put different priority for different phase, the progress will be different. So how we want to solve this kind of problem, so we developing and then the formalized Q-learning based schedule generation methodology. So we will define some of the things, how much percentage of exploitation we will do, and how much percentage of exploration we will do, something randomly, action. So, and then we can now develop this kind of Q tables considering resource prioritization policy and excavation state. And then based on that, this is one example of our Q tables, what that can show. And then just for when he have this kind of excavation state, and then using this first come, first serve will be the best policy, best resource allocation policy, and this case different state, when you have a different state, and then this Q-learning method will give us the solution. This case, you will have to use mean select. This is different resource allocation policy. And then we actually apply this to actual construction project. This is some more detailed information, but and then apply one simplified one tunnel project in Korea. And then we use this kind of first come, first serve, shortest operation, or this kind of the policy we consider. And then, so the result is that actually, there is actually tunnel construction project, we have lots of uncertainties in ground condition. So we assume first one, like a first training set means actually we know everything about ground condition. And then based on by using this Q-learning method, we can save 2% of time. And then when we use uncertain ground condition, now actually our result is our method. If we use our method, we can save like a 0.5% of time, but we are still developing better Q-learning algorithm. This is what we are doing. And then just another thing, this is actually done by with the Dr. Chen. So this one example is that actually action recognition is really important for our industry. One thing is important for the health problem, and another thing is actually check productivity. If we know some specific action, and then we can check productivity of labors. So there is two different perspectives for us to see about action recognition. So we can use RGB image, and also RGBD image is including depth image, because when we use this, we can use some of skeleton information. And then we can do some low computation. If we use skeleton data, it will be good for us to use like actually low computational resource, and then several advantages. So we selected use skeleton data, And then this is some example, just RGB, the difference between RGB video and RGB video. This is like this depth image we can collect in addition to the data about RGB video kind of things. And then, so also we need to consider some specific characteristics of construction activities. Especially we realize that we have to consider the relationship between two hands for construction things. And also we consider this kind of attribute in our the model, and also even the same activity, there is different postures. We needed to consider this kind of the characteristics in the characteristics for the action in construction project. And then this is more detailed. So we added some 6 different representations. And then finally, just briefly introduce, this is develop this multiple input stream attention network. Based on that, we can finally get this almost accuracy is 85% of accuracy. Usually comparing with it, this is baseline. If we don't use this kind of 6 additional input, we can get 75 accuracy, but we consider that kind of some specific aspect of construction, we can increase the accuracy of our action recognition. And then next one is something about operation phase. So this is done by another PhD student. She is here today. So we are doing something for road construction project, especially road maintenance. We are doing a lot in the city area, urban area, but there is still aging problem, something aging also from the utility construction and some disaster. We have to do this again and again. But we need to find some optimal solution for this kind of actions, because you experience something about the traffic jam caused by this kind of road maintenance project, especially in the city area. So this is what we have to do to figure out good, the road maintenance plan. So basically, we need to consider rehabilitation space. This means maintenance space. And then we have to consider just the workspace. We can do everything at the same time. But in that case, our traffic with this kind of action will affect a lot for flow of the traffic. So we don't want to bother them. So try to make it smaller and then cut, divide, split like this. And then also we have to consider some buffer for the safety. Kind of, we call this temporary traffic control zone. And then using this, finally, we can evaluate the mobility and safety performance of this road maintenance plan. So we have to do this again and again. But actually, in actual practice, it is very time-consuming, also very complicated. So usually planners not doing this, just they make some decision based on their previous experience. But we want to actually consider this kind of things more structural manner. So we develop, this is also another problem, is that usually previous study mentioned something about highway maintenance project. In that case, they don't have any disturbance by a signal in the in the city, and then their traffic is very even if they block the different area, but their traffic is very stable, consistent. So they don't need to consider something about additional simulation kind of things. They just based on their previous observation, they can understand or they can predict how much the disturbance they will make for traffic flow. But our case, specifically for the urban, in the city area, will totally different. Will have a totally different situation. So as you can see in this part, especially this part will have this amount of road disturbance, the resulting from the road maintenance project. and then we'll have a different impact differently. Not average value, we cannot use average value for this. So we have to incorporate something about the actual simulation things into our decision-making procedure. So this is something I mentioned about load rehabilitation. To consider that, basically we develop model for the a work zone planning model developed, and then we also based on the work zone developed, and then we have to analyze performance of things, especially mobility and safety. And then we develop this kind of module or domain-specific engine by using some microscopic traffic flow simulation tools. And then finally, using that, incorporate that into one system, and then figure out collecting some data, and then based on that data, we actually can carry out some optimization procedure for work zone planning. And then, so this is what we have done. Basically develop, as I mentioned, we formalized information required for this urban road planning, and then just using IFC, this is global standard of BIM I mentioned, and CTGML also global standard of GIS, and then we extended that representation, the information, and then we integrate the system, and then to support automated the plan generation and evaluation. And then using this is what we have done so far. And then this is some example based on that. As you can see, this is relatively like a small video, but you can see when you have like a work zone, there will be some different traffic flow comparing with without work zones. So we can consider this kind of things again and again based on our automated procedure. And then finally, we develop, based on considering that, we develop some optimization process incorporating with that the building information modeling and GIS, also considering some traffic flow simulation tools. And then so now actually this is also ongoing project. We are trying to develop some optimization algorithm, and then we'll show you better result later. And then I will give you my conclusion. So basically, at the beginning, I mentioned we have actually, we will contribute to enhancing the implementation of AI during the whole life cycle by collaborating with multiple disciplines based on BIM kind of a database, and then adapting emerging technologies. So kind of my goal, or some of my career goal is that from this stage, I want to improve the level of digitalization in construction industry, and then this will contribute to improve the productivity of construction industry. That is something something I wanted to do. Yeah, that's all my presentation. Thank you.
Questions from the audience? If no, maybe we can go straight to the discussion section. Before passing the time back to MC, let us thank our speaker again.
Thank you very much for all of the insightful sharings on AI in construction industry and the applications. May I now invite the speakers and the moderator of this session to take a group photo first. Professor Lau, Professor Chan, Professor Chen, and Professor Kim, please. Yeah. May I invite all the guests to look at the camera in the front? Thank you. And this marks the end of this section. Please be seated. Now we will have the panel. We'll start the panel discussion, and I'll pass the time to Professor Lau again. Thank you.
Thank you. So we may still have about 15 minutes for the discussion section, panel discussion, and in fact, we welcome the question from the floor. In fact, today is very pleased to have a lot of insightful talks related to construction industries. And we know that it connects to a lot of different construction stages, also linking up to the circular economy. But one important thing that I think Professor Jiayu Chen mentioned that it's not just talk about technology, right? It's really linking up to the social issue eventually, because if we just use AI directly, I'm sure there are a lot of clients, developers, is that they just want to save money. So in fact, my first question maybe in this section is, how can we really strike a balance that we can make sure that the social aspect, people can still find job, at the same time we can still do a very good advancement in the AI implementation aspect. Any feedbacks from maybe Professor Chen? Yeah.
Okay, thank you, Professor Lau. It's an insightful question, in fact. I know there is a saying that if you develop AI well, you do not need to work. If you develop AI not well, you will lose your job. Seems the final destination is quite alike. But the difference is what type of job as a human being can do. It's very interesting observation in the past decades that originally we think a lot of creative works as a human can do cannot be replaced by AI. But the fact is, a lot of work that's require creativities was replaced by AI, especially like stable diffusion, like we watch in the morning. A lot of designers tend to lose their job, but like construction workers seems they have a better condition because their job can never be replaced by robots or AI. So my guess is how to develop AI is highly depends on the nature. If the job can be decomposed by some repetitive and how can I say, repetitive and simple works. It's not that simple, but if a person is versatile, like even if they are focusing on one type of job, they cannot be easily replaced. That's the benefits of human. But for the AI, no matter what complicated algorithms they are, currently I see is they can only do one job. So my guess is AI may be not able to replace human, but the survival technique for us is probably beyond our imagination. So my suggestion is you probably learn how to never stop learning. That's my solution.
Thanks a lot, Professor Chen. Yeah, maybe Professor Chen, any insightful comments in this area?
I think that's a very good point about the not survival, probably the balance between the AI or what the human beings are working on. I keep on asking the same question to myself. Sometimes probably the personal touch is the very important things that no matter we're doing design and construction, and when I look into in the construction industry, when we look into our society, probably look at the aging issue that about our workers. So I think because the perspective about being a worker that may not be attractive to the youngster. So the average age is about 50 years old as a worker. So by then, that means we need to develop something that to help the construction industry to try to simplify the work. Some of the repetitive works, like the laying, the paint, that kind of things, I think that we can explore this area and make good use of it. When going back to the basic about the design, the creativity, which I mentioned, I think we have so many databases, and then we can develop the algorithm. But at the end, probably some of the artistic things will just come in one go, just from human brain. And those things is very crucial. That need the human being to develop the experience, enjoy the culture, and then they will come along. So that's why hopefully in our education system that we can bring along that all our students need to make sure that they have the core knowledge about the construction, structural engineering, mechanics, to make sure that they have this core value, so that when they come upon to make the decision, then they can actually make use of AI to help them. Not need to worry about that they will place them, because you are the one that in control. So hopefully we can build up this momentum to our next generation, that they are in the driving seat, actually. So they should make the decision where we should use the AI to help us. So I think hopefully that we can do that.
Yeah, great, thanks. Professor Kim, do you have any comments?
Yeah, actually, I received a similar question from I worked for construction company 20 years ago somehow, and I met them sometime and explained what I'm doing. And that they really hate what I'm doing, because they mentioned that if you develop these kind of things very well, they will lose their job. But I explained, actually, mostly we spend more than half, the 50% of time to extract data. So usually they're very repetitive and like a low product tasks. And then basically my research was doing is saving that time. So you can do, if you are very expert in that area, of course, even my system and other system developing these days, not perfect. So human expert need to check this result is correct or not. That kind of very high quality tasks people will do. So that is my explanation from my perspective. So in the future, of course, the technology will be improved, but still humans' idea will be more important. So at some point, so that is, so we believe that technology will not be very perfect or something, or still need some input from experts. So that is something we can. Yeah, think of that.
Thanks a lot for all the comments from professors. I hope that this feedback can also give the audience some take-home message, right? And not just focusing on technology indeed, when developing some new technology, implementing in certain areas, I think really we need to overlook a couple of areas that will really affect our society, our community quite significantly. One more question that I think audience may also be interested, because when we are looking through the slides, we see a lot of implementation of AI in the construction site. But at the same time, we can also see that there's still a lot of, accidents, right, in the construction site. Or particularly in Hong Kong, we can't really see a very significant decrease in terms of the number of accidents. Is there anything related to the AI implementation? Is there something related to how they share the data between contractors, or are they willing to share? Well, what is the reason behind, from your perspective, really? Any feedback, comments, or even from the floor? I think that's also good for interact. I think this is also really what we can come across, right, in the newspaper, in the media. That is quite being emphasized in the societal sense.
Probably, just some view on that. I think we observe a lot of things happen in life in the last 5 or 10 years, in particular in construction industry, that the fatality that we observe is one of the sad story on that. But obviously that the interaction that I think as the operator or a human being, we should bear the responsibility, because the one that who will make the decision, make the call, whether you use the crane or whatever. So it ultimately go back to actually the first question, how the human and AI work together. Actually now it's the human that we need to be in control. And with but we have a lot of policy and standard regulation. And then at the end of the day is whether each of us get the chance to appreciate, respect those procedures accordingly. So that's why I get, as always, I don't know why I keep on saying about education or training. So I think at the end of the day, really to train up ourselves to how to, in this industry, not only about in construction, in other aspects as well, is really need to understand your role, your responsibility. But that only comes through the education, training, and the understanding. But sometimes because of the Asian environment that we are in a tight time frame, it's also the societal issue that we need to address, how to keep a balance. So I think just we have to, as a human being, that we have to take in charge of that one.
Okay. I read a report that, for example, the construction accidents, majority of accidents, more than 60% of accidents actually is the results of unsafe behavior. People, as during the talk I mentioned, everyone is lazy. I can give you one example. There is one trade called a stone worker. I'm not sure if you know this type of worker. This type of worker is work on the steel structures, on the top of those steel structures. And they work there. Usually, they were asked to wear some devices, safety devices, called harness. This basically harness looks like a cage, like steel cage. The weight of cage, actually I wear this type of harness before. The weight of the cage could be 20 kilograms. It's very heavy. You ask people to wear those cages while they are working on the steels, no problem, because when people fall from the steel beam, like the harness will save them. But think about that, you wear this every day. It's so heavy, take you a lot of effort. So that's why the majority of workers actually, they don't wear them at all. So whenever there's an accident happens, and then it's not only problem because of uncertainty or any problems, just randomness, but it's just because they didn't actually follow the safety regulation. So my suggestion, like in future AI, is it's not saying, okay, I will forbid people to not doing that or like being lazy. I think it's if we can develop some more lightweight devices or like more comfortable devices, people could easily accept. They would be able to avoid those unsafety behavior. So I guess in this case, we are not considering about the safety of the whole project, because in that case, you assume you're a project manager or you are the owner of that project. You're not thinking about yourself as a construction worker. We have to change our perspective. We think about if we are a construction worker, what type of device we like, what type of convenience if they can provide us. And then I think that will improve the condition.
Okay. I think, in fact, today, after listening to 3 important talks in this area, I think really an important message is that we are not going to be replaced by AI. I think it's a consent from all the speakers. It's really an integration between human and also technology. And that's why my question just now, I think we should not really just linking up to the AI for the resultant that we observe in the tragedies or accidents. I think humans should take a very important lead, and that's also why I think Professor Tak-Ming Chen also mentioned that education is very important, right? And that's also what we can observe from various universities, that even though it's very tough to change the program. I remember that this morning, I still remember that there's a talk about changing the academic program. It's very, very difficult, right, from Professor Stanley Chen. And, but I am sure that even with this obstacle, we are still trying to implement a lot of AI element into our curriculum, technological related element on top of the existing program. I hope that this is really what we are doing, is addressing the need from the society. Before closing today's this section, no, in fact, we have a following up section very shortly. So any questions from the audience indeed, because we don't have too many Q&A section just now. Yes, please.
So we were reminded earlier that generative AI can make these cool things like images and videos. And how far are we from asking generative AI to design a house or something like that?
Yeah, actually, like using generative AI for the design or things, we still actually, based on my idea, based on some automated procedure, we can apply that for the different type of facilities. So we are still ongoing, and some of them show some very simple things, but still, they are still conceptual design phase. So will be developed for more detailed design phase, we will see. So there is much more like advances will happen in the future.
Any other comments from the speaker? Yeah, Professor Taming Chen.
So I think probably you observed early presentation from Professor Chen that we used to use the paper-based documentation. But I think this day now, all the drawings, architectural drawing, structural drawing will be digitized. That means in the database, that means you can develop, well, for office building, what is the layout, how many story, school, there will be a lot of different database. So when we look into the generative AI, that means they can adopt those parts, but obviously it depends on the region. That means if you design in Hong Kong, it may be different from other parts. But I think if you add this feature, then actually you can generate the concept, sometimes even the structural design as well. But obviously, going back then, the engineer need to take the leading role to assess if they are really suit the purpose of the clients or developer.
Okay. My answer is, you see, for the building, it's have different phases. They have design phase, they have engineering phase, they have construction phase. For the generative AI, in fact, I saw a lot of application for the architectural design. Like they can bring some ideas about some concepts for the architects. But for the civil engineers, usually, for example, like how many columns or how many beams here, it highly relies on computational calculation on the load capacity of a building. So generative AI, they can generate ideas, but they cannot compute, like how many people this floor slab can bear. That's a problem that they cannot solve. So I guess at this moment, maybe architectural design could be a very good starting point.
I hope the panel can answer the question. Yeah. And I think in view of the time, really, we may need to conclude our section here. I pass the time back to our MC. Thank you.
Thank you very much for Professor Lau, Professor Chen, and Professor Kim for all the insights on AI implementation. And I think it's really important that education and training will take an important role in improving the construction safety. And we should all coexist with AI along the way moving forward to improve efficiency and productivity. And now, may I invite all the speakers to be seated. We would now have a coffee break. The next section will start at 3:50 p.m. and see you in 15 minutes. Light refreshments will be served in the foyer. Please enjoy and please use the front door to lift to the foyer. Thank you.